Hello, everybody. It's already our 6th meetup with Sitecore User Group Baltics, and we promise you will find lots of interesting and useful information for yourself again. So here is the agenda, briefly. We are starting with the first topic will be getting Sitecore latest and greatest together. Sitecore 10.1 plus JSS plus SXA plus rendering host in AKS by Artem Prashkovich. So let's jump to the first one. Artem Prashkovich. It's a solution architect, Sitecore MVP for the past 4 years already. Sitecore certified enthusiastic developer with over 9 years of experience. Experienced in .NET developer, and certified Agile master. So Artem, are you ready? The stage is yours. Yeah, guys, you can find the links to the profiles also in the chat. So meet our speakers.
Thank you, and hello everybody. So let me share my screen and start the presentation actually. Okay, so here we go, and I can share my screen. So do you see my screen? Is everything fine?
Yes, we
Cool.
see the title.
That's good already. Okay, and let's start it. So my name is Artem Prashkovich, and today I will talk about latest and greatest technologies that we use to build the project for one of our customer. So actually it's the saying that it is Sitecore 10.1, but actually it is probably the same for Sitecore 10.2, and so nothing changed in terms of technologies and approaches to build the same even with the latest Sitecore version. But anyway, we will talk about it later in more details. And let me start with the presentation with short introduction of myself. So I have more than 11 years of programming experience in general, and since April 2012, I work for Breemit, and for all of this time, I work only with Sitecore. So my Sitecore experience is like around 9 years. As it was said already, I was awarded the Sitecore Technology MVP for 5 times in a row, and I'm live in Minsk, so actually I'm here as well. And with my next slide, I want to say a few words about the project that we have done already. And once our client, our customer decided to stay unrecognized, I will call it like just a corporate website project. And when our customer came to us with the initial requirements, that was like only few of them. It should be like a Sitecore application, the application built on Sitecore, and so it should use SXA. That's all what client wanted from us initially, and so as our client is a Sitecore partner, and which means they are not limited with any Sitecore licenses, and all scope of technologies are available for them. So we just prepare a new approach to build the same. And after a few rounds of discussions, we decided that that it still should be Sitecore for sure. We also decided that this project should be built according to the headless architecture. It should use some rendering host. So actually that should be .NET Core rendering host, because we can still consider that rendering host can be built on the Next.js, for example, and other technologies. But in our case, it is .NET Core application. It still should use SXA, and all this stuff should be deployed to the Azure Kubernetes services. That was our initial scope of technologies that we decided to use to build our project. And so Last year showed that the headless approach becomes popular. We got a lot of requests that for projects built on the headless with different variants of front-end part, but anyway, that's still headless. And headless evolves rapidly last years, and from my point of view, it is becoming like a primary approach of building modern composable DXP solutions. And the number of Sitecore acquisitions, all being headless and SaaS, just confirm that. So, and this is my first JSS related topic, since Sitecore have been announced the JSS as a technology a few years ago, and during this time, the JSS term has undergone changes, which I'm just going to shortly describe. And initially, JSS or JavaScript services was presented as a toolkit for JavaScript developers, allowing to build full-fledged customer solutions like single-page applications, web applications, websites, and using modern JavaScript libraries and frameworks, and be completely unplugged from Sitecore. And so initially, the JSS term consolidated tools and APIs such as layout service, dictionary service, GraphQL, etc. And so, and it is still true, but in Sitecore 10, the composition of things was changed a bit. And looking at the current diagram, it is how it looks in Sitecore 10. And we still can see that Sitecore collected all headless services in separate module and call it like Sitecore headless services. It is not a JSS anymore, so we can see that we have like JavaScript SDK, which is before was known as a JSS. So JavaScript or JS SDK includes some templates for different various of JavaScript frameworks, like a boilerplate that you can start with your project. Just running a few commands, you will get like your physical structure of application. And also they have .NET Core SDK. This is the number of nugget packages, let's say, or assemblies with predefined HTTP clients or everything you need to work with Sitecore through the GraphQL or even layout service or other things. So that's kind of stuff that you have to use when you want to communicate with Sitecore and build your headless architecture. So as a previously, Sitecore headless services include layout service, so which is the main entry point to communicate with Sitecore, and for headless applications, there is still GraphQL endpoint, what is dictionary service, which is also used for translations and so on. We still can see that Sitecore started using layout service for SXA, but in this case, in case of SXA, the layout service provided within the package of SXA itself. We don't need to install them separately. And yeah, and at the bottom or even the main part of the project still Sitecore. So, but yeah, we just extended with separate packages just to be able to use it as a headless CMS. So when I just started working on the project, before I was working only with JSS and some JavaScript frameworks. Mainly it was React or Vue.js, and probably everybody who know what is a JSS always think about some JavaScript frameworks. But when we decided to use .NET Core rendering, I faced a new term in terms of JSS, and this is a Sitecore headless development. And I was quite surprised because it seems like it has existed like years, but I haven't heard about it before. And I just started looking at it more deeper. What is it? And actually, I figure out that it is not like a technology, so that cannot be technology. Just an approach how we can build our headless applications, and mainly using the rendering host, .NET rendering host, or at least this particular diagram describes the how to work with the ASP.NET rendering host, but it probably will be the same for rendering host based on the some Node.js server, even it's React or Next.js, doesn't matter. So looking at this diagram, we can see that on top of this approach, we have Sitecore, which have a few additional models installed. And first of all, this is headless services that we saw on the previous diagram, and which includes layout service and rest of them. Then we have Sitecore management service, which is a separate package that we have to install on Sitecore if you want to use Sitecore CLI. And in terms of .NET SDK development, we mainly use Sitecore CLI to perform serialization because we have used Sitecore serialization. This is a default serialization tool provided by Sitecore within Sitecore 10. And yeah, so this module allows us to communicate with current Sitecore instance through the PowerShell. And there is also mentioned like Sitecore Launchpad, but it is not a module, so that's kind of entry point for content authors. When they are working from their working station, just they connect to the Sitecore through the browser. This part is not changed in terms of headless. That's still the same. So also we have a separate node here, which is rendering host running on some web server. And in terms of .NET rendering host, it can be run even on the Linux machine. Doesn't matter. So where you run that. So that's just should be a web server. And we have a workstation, developer workstation, let's say, which developers use to work on the project, which is obvious. And our project, we work with our project using the Visual Studio mainly. So, and we have installed and used some rendering SDK that we saw again on the previous diagram. So this rendering SDK is like main part of that we use to this main part of the solution that we use to communicate with Sitecore. And and we have like a public part where our visitors just browse our website and request any pages. So what's happening when a visitor just requests some page from our website? And it is functions in the following way. The visitor sends a request to the web server, which activates the rendering host web application, and the layout service client. We can see it here. Fetches the relevant content and presentation data, let's say the data model from the Sitecore headless services from the Sitecore itself. Then the layout service client passes the data module to the rendering engine, which is also a part of rendering SDK. And once rendering engine renders the data model and your code and static resources into the final response and send it back to the visitor. So we have like two main entities in this architecture, like a rendering, like Sitecore with data, and predefined presentation. And we have a rendering host which is responsible to map, let's say, data which come from Sitecore with some presentation implementation. So as I mentioned, we still wanted to use SXA, client wanted to use SXA, and at this time, the ASP.NET Rendering SDK does not support Sitecore Experience Accelerator renderings, which means we cannot use predefined components provided by SXA, but rendering hosts can be used with the existing JSS tenant and SXA to take advantages of features such as multi-site designing and partial designs. So that's still useful to have because we can easily create new websites just using a restricted number of features provided by SXA, but the main part of them are there. Yep, so that was our client wanted to use SXA just to be able to manage multi-sites easily. So, and this requirement was covered by existing features supported by JSS. In Sitecore 10.2, something becomes different. As far as I remember, Horizon started supporting JSS and SXA as well, so that's a bit more flexibility there. But yeah, the default components are not supported, still not supported. So my next diagram is really popular in Sitecore world. So maybe I saw that diagram a lot of time, but I also put it here because I want quickly explain the flow of the development using containers and using AKS as a final hosting. So the left part is clear. So we have a developers with Visual Studio, let's say, and once they push some code to the source control, some trigger run the build of images in, for example, in Azure DevOps. So, and what happens in this stage? We just get latest code. Build pipeline downloads the base images provided by third party, but mainly that's from Sitecore. Even when we deploy our code to the CM or CD server, we just use base Sitecore images for CM or CD server and just upload our custom code on top of them. And once our custom images are ready, build pipeline just push them to the container registry. That can be any container registry, but mainly we use the Azure container registry within the same cluster and within the same resource group in Azure. So, and when we ready to deploy our changes, when containers are pushed to the registry, we just run our deployment pipeline or release pipeline, which mainly do nothing with AKS itself. It just say AKS pull latest images from container registry. So we are not we are not upload anything except some secrets and some specs to the AKS. We just say them to get latest. So, and AKS do that themselves. And there is some advantage of AKS because when we send the command to get latest images, it is running behind, so nearby with existing pods, let's say. So I will explain it with next diagram. But anyway, when we have, for example, CM node running in AKS, and we want to deploy the new one, the old one still working until new image will not be running successfully on the AKS and test it. And once AKS understand that new node is deployed and it is ready and functioning, then only after that the traffic will be switched to the new one and old one will be terminated. So mainly we have like a zero downtime in terms of our deployments. And only one thing that our release pipeline do behalf is the uploading and saying to upload no new images is just content serialization stuff, because our images does not include any serialization data. All serialization data usually is a part of artifacts for our release, and when we just execute our deployment, we run serialization command, like some PowerShell scripts, to push our content to the AKS on top of the new image. So the next slide describe our AKS infrastructure that we have in Asia. So, and here we can see that it includes some basic stuff like resource groups. So the resource group can include everything you want, but mainly it is per client or per project, so it depends your needs. But anyway, it also have AKS cluster, which is already created based on some region. So for example, when our client is in West Europe, we just define that we want to create our Kubernetes cluster in this region, and we hope that it will respond fastly, but who knows. And then inside of cluster, we have the main piece of architecture, which is node. And by default, any cluster have to include Linux node, which is system node. And basically, it doesn't have anything custom. Like by default, it just include maybe some ingress stuff, ingress controller running there. Also, for non-production environment, we are running SQL Server and Solr and Redis. So we don't spend the resources in our main Sitecore node, which is Windows. We just use the resources available by default in the AKS cluster to run some extra stuff required for our non-production services, non-production infrastructure. So if you will look at the Windows node, and all Sitecore stuff can be run only on Windows node, we can see CM, CD, identity server, rendering, and rest of the infrastructure pieces here, but mainly in Sitecore or in the AKS term, it is called like pod. Each icon here is a pod, and each pod that should communicate with outside resources, outside the traffic, each pod that can be available from outside should be wrapped with service, and service in terms of Kubernetes used for communicating between pods. So each pod can be available outside using ingress controller. Ingress controller has external IP address, which is available for visitors, or probably it is mainly available achieved by adding some DNS records. And when we just put some not IP address, or some host name in our browser, we will just be faced we will be route to the Nginx controller, and the Nginx controller, based on the host name that we put in the browser, will follow us to the corresponding pod here. So even it is identity server, CD server, CM, and rendering host. So, but in our case, CD server is not utilized from outside because we use a rendering host is our main entry for external visitors. So rendering host communicate with CD server, and visitors itself communicate with rendering host. That's all what's happening with CD server. And of course, this is like an optimistic diagram. So of course we have like a front door behind of ingress control just to protect our pods from outside traffic, unexpected outside traffic, let's say. So there is possible to use some traffic managers and other Asia stuff. So that's just this diagram just explain mainly the architecture of AKS clusters. So what we have for production actually, and only one difference here that Sitecore suggests to use different and third-party tools for SQL, for Redis, and for Solr, because when we run them in Kubernetes, they are like stateless. Everything what we have in Kubernetes mainly stateless, so we can just remove one pod and it will be created again with, let's say, from the beginning. And when we run, for example, SQL Server as a pod inside of AKS, and for example, we will remove them, we will lose all data that we have in our SQL Server. So it is not a good idea to run it for production. If it is fine, for example, for dev environment, it is not really possible to run it for production. So for production, we always have our SQL Server running separately. It can be any SQL Server. In our case, we usually use Azure SQL with some Elastic Pool running on top of that. And we also always usually run Redis as a Azure Redis. And for Solr, the best option is search stacks. But for some of some of our clients, we use Solr we run Solr within the Kubernetes in the same way as for dev environment, just because of money. So the search stacks are quite expensive, and if this is not like a search-driven website, if there are not a lot of data goes from the search, they are just agreed that they understand that they can lose this data and they will have to rebuild indexes in case of any disaster. And for example, Solr was removed from the AKS and all data has disappeared. But yeah, we can still just rebuild indexes and they will come again. So this is something that we can accept, let's say. So this is what about our AKS cluster. And now I will show a short demo, and I will show how we build our solution in terms of using rendering host. So when we just started working on that, rendering host is .NET rendering host, .NET Core rendering host was a quite new technology for us. So we haven't had any experience with that before, as well as our client. And they asked us how we are going to follow Helix architecture and Helix principles, and how we are going to build our application itself. And so now we can see that we still follow Helix. We have feature, foundation, and project layer. But if we will, for example, look at the project layer, we can see that we have two types of project. One for rendering, and it has like a rendering postfix, and then we have like another project for which is have a platform postfix. The platform is always include some stuff for Sitecore. It is not .NET Core stuff, because as we know, we cannot run .NET Core within the Sitecore, because Sitecore does not. It is not a .NET Core application, so that's standard .NET application, ASP.NET. So yeah, we just separated stuff required for rendering host and for Sitecore. And for example, our basic content have just a few content resolvers required for the components that we are defining in the basic content, and the basic content rendering project will include already the components itself in their implementation. So, and what's happening when we want to create a new component, and we want to create a new component in the rendering host as well. So let me just quickly have a look if it is running already. Corporate. Yep. Probably. So this is a website, corporate site that we implemented. It is running locally. So everything here is expected. So I'm just was run it a bit slow yet, because it took a lot of resources for Docker. Yeah. Oh, this is a test website, by the way. So if something doesn't work, that's pretty fine, because yeah, I just got the code maybe 5 months ago when the project was still in progress, and remove everything that can talk us about the client, just because, as I said, client decided to stay unrecognized. Okay, well, until it is loading, I can show the another stuff. So, okay, then we created the standard rendering in Sitecore, as we do that for JSS project. The rendering in Sitecore just include the name of the component, and we define the data source for the component in Sitecore as well. And what is the first step in our rendering host? We just need to define the model, and for example, image with left text. So it is our main entry point to our component in rendering host. We define the model that we will use with the component, and this model should follow the same structure and the same fields that we define in data source in Sitecore. We also use predefined and provided by rendering SDK fields for each text, for image, even for just simple text. For links, we have a own field type. All of these field types are provided by Sitecore assemblies, by, let's say, by Sitecore Rendering SDK, as well as we can extend them with our custom code. Maybe some, I don't know, if you need to add some additional logic for your model, you of course can do that, or even you can implement your custom fields. This is just deserialized. The field itself is just deserialized data coming from Sitecore through the layout service. So let's say we predefine the model. Model can be nested. We can use, like, for example, if we have some multi-list field in Sitecore, and it is follow, and we select some FAQ items there, we of course can define the global model, which will include children or fields from the multi-list field as well. So it is very similar as we work with Sitecore and, let's say, with GlassMapper or so on. So when we have the model, we need to define the view. And for example, FAQ view, it is very similar view as it was used in Sitecore before JSS come to us. So it is, if it's not a riser, but it's very similar to riser that is used with MVC. We have some Sitecore context here, and we can define if it's editing mode or not. And this is required for let's say for experience editor. So if you want to be able to be managed in experience editor, we have to use the predefined types of field by Sitecore again. So because this field will render additional stuff required for experience editor, but if we just need to render the text outside of the experience editor, we can do that easily. Sometimes it's just enough to use only this field, but it doesn't matter. So that's kind of another discussion. So we have some the main idea that we have some predefined fields provided by Sitecore as well here. So then we just render our list of items using the same predefined fields as well. So now we have a view. Now we have the model that will be passed to this view, and what is left is just to map our model with some component name. So in this file, in this class, we can see that we map, for example, FAQ model to the component defined in Sitecore, and which have FAQ name in Sitecore. So this is all what we need to do. So we just define model, we define view itself, which use this model, and map the component name to the model. So basically, the view should have the same name as well. So what else we can do is that, what if we want to do something with data before it is passed to the view? So because right now we just defining the model and pass it to the view. Nothing else. We can do that not right now, but there is another option that we can utilize. And if we'll look at the navigation project, in our case, there is like a view components, which is a part of .NET Core itself, and this is like a special class which have a name like view component, and here we have invoke a sync method, which we can use to prepare data for our view. We can look at as it is similar to controller that we have in our standard MVC applications, but with only one method, and we have to define it for each component separately. So and we have our module on incoming to this method, so we can get it, and we can use this data, let's say, to retrieve or extend this data with some additional data. So in our case, we use Solr as to get some, let's say, related articles, for example, and we decided to don't send requests to the Solr through the Sitecore. We don't use Sitecore search to get some data from Solr, because .NET Core can work with Solr directly. So that is like .NET Core itself. It's a powerful thing. It can do everything that our backend, or let's say our .NET framework, can do. So, and there are a lot of libraries that you can use with .NET Core to communicate with third-party services in tools like such Solr. So, and we define that we decided that we will use Solr directly, and the components, for example, as I said, related articles, just it's that data source just include, for example, some parameters that we need to build our request to Solr. For example, the base template that we should filter our results from Solr, maybe the number of results that we are going to use, that we are going to get from Solr for this component, some basic stuff. Then we use this data to build our query to Solr. And once Solr responds something for us, we just return it to the view. So this is a case when our data source is not really data that we are going to show on website. The data comes from third-party services, such Solr. So then,
just a quick reminder about the timing. How far you are from the end?
I'm pretty close.
Okay, kind of 5 minutes is fine, right?
Yep.
Okay, good. Yeah, thank you.
Yep. So this is how it works when we want to get some data from outside of Sitecore. And there is another. Okay, this is not here, but there is another command is used to add this add view component, and here we also define model and the component, like it's for standard model bounding, but for we just use another command to add the view component. So this is what about this part. And yeah, so this is our Sitecore instance already prepared. From the Sitecore point of view, our project looks pretty standard, nothing unexpected from here. Only one thing that I should mention, you have to have a lot of memory on your laptop if you are going to use Docker. Because when I'm just running my Docker instance just before a few minutes before our presentation, it is still use a lot of my resources and it's extremely slow. It is not always, but as usual on presentation, it becomes slow. But by the way, my laptop have like 32 gigabytes of memory, and yeah, it is not always enough. This is our corporate website, which is represent the SXA tenant, and global is SXA site. And the structure looks very similar with SXA, but we have less settings here. We have less presentation options here. We just can define page designs, partial designs, and that's all. We keep our data sources in data folder as well as in data folder under the pages. That's always similar to the SXA and implementations. So, and maybe let's have a look how our components looks in the Sitecore, which is very general. And for example, FAQ, as we was looking at it previously. Yeah, the main thing what we have to do here is just define the component name, and this component name will be used to map our model and view to this rendering that are put to the presentation on the item. Yeah, there is nothing else interesting. We defined the data source template, data source location if it's required, and rest of standard Sitecore data here, nothing unexpected. So, and maybe last thing that I will show, I think I have just a few minutes left, is how, just a second, how our project looks from the physical point of view. I forgot how it looks in our disk and our storage. We have, just in case, I have added a separate Docker Compose files for different just for our CI/CD pipelines, because if locally we need to run, for example, all of our instances, like we need to run identity server, CM, Xconnect, all rest of the stuff required for XP1 topology. And once it is run in AKS, we don't need to deploy it every time. So for our deployments, to production or even to our dev environment, we just utilize, for example, we just build much less. We just build our solution code, which is required. We build rendering host. We build SQL server as an init image, and the CD, CM, and identity server. Everything else is not required. It shouldn't be built every time. So that's always makes sense to separate the Docker Compose files for your instances. So because locally you have to run much more, then you need to finally update in your environments. As well as we have a definition, or it is called like specs for our Kubernetes stuff. And again, we have a different number of definitions, for example, for integration server or dev server also. It is known as a dev server, and for production. So because for production we don't run SQL server within our Kubernetes instance, but for our integration server, we run everything in Kubernetes, so they cannot be the same. We always define each environment separately. So, and all files here just describe our environment. And this is just YAML files with some Kubernetes related stuff, with environment variables defined here, with service, which I was mentioned previously. We run service for our application, which is called CM, and the application itself is defined a bit lower. So it is our instance of CM server. So that's not make sense to state in more details, because there are a lot of stuff that we can discuss regarding the Kubernetes that require additional and separate topic to discuss the Kubernetes itself and how it works, how it deploy, and the rest of the stuff required associated with Kubernetes. So I think I'm pretty all. And thank you for your attention.
Yeah, thank you. I think that was a great